Hello and welcome to Advanced Digital System Design playlist. Today we're going to study about delay flip-flop or D-Flipflop. The D-Flipflop is a modified set-reset flip-flop with the addition of an inverter to prevent SR inputs from being at the same logic level. What D-Flipflop actually is a modified set-reset flip-flop with the addition of an inverter. We usually connect inverter between the set-reset input of the SR flip-flop to give only one input, which is called the delay input or D input. This prevents the inputs from being at the same logic level. A D flip-flop is used to delay the change of a state of its output signal Q until the next rising edge of a clock timing input signal occurs. Usually the logic symbol of the D flip-flop is shown here. It has a D input and a clock and the output Q and Q bar. Its logic diagram is shown as it has two input NAND gates and a latch. Two input NAND gates have the same single input D, which is connected through inverter to another NAND gate. Usually it has a single input D, which is connected to one of the NAND gates, and this input is connected to the another NAND gate through an inverter. This completes the delay flip-flop logic diagram. Its characteristic table can be obtained by plotting the four combinations 0, 0, 0, 1, 1, 0 and 1, 1. We have the D input here and the present state Qn here. We have to find the next state Qn plus 1. We have to remember next state Qn plus 1 is equal to 0 when input D and current state is equal to 0. And it is equal to 0 when input D and current state is equal to 1. The Qn plus 1 is equal to 1 when input D and current state input D is equal to 1 and current state is equal to 0. And Qn plus 1 is equal to 1 when input D is equal to 1 and Qn is equal to 1. We can obtain the simplified characteristic table from this table. We usually don't care about this Qn because it can be either 0 or 1, 0 or 1. So we write D input, which can be either 0 or 1, and we write the corresponding output, corresponding next state Qn plus 1 for the input. For the input 0, when D is equal to 0, Qn plus 1 is equal to 0. Similarly, when D is equal to 1, when D is equal to 1, Qn plus 1 is equal to 1. This completes the simplified characteristic table. We can obtain the characteristic equation from this characteristic table. We plot the K map. In cell number 0 we have 0, in cell number 1 we have 0, in cell number 2 we have 1, and in cell number 3 we have 1. After necessary grouping we get Qn plus 1 is equal to D. This is the characteristic equation of the D flip-flop. The excitation table can be obtained from this characteristic table. Here we have the Qn present state and the next state Qn plus 1. We give the necessary four combinations 0, 0, 0, 1, 1, 0 and 1, 1. And we check for 0, 0 in characteristic table, which is here. This corresponds to D input being 0. So we write 0 here in the excitation table. For 0, 1 we check 0, 1 is here. This corresponds to 1 input of the D. So we write for 0, 1 is 1. For 1, 0 we check 1, 0 is here. This corresponds to the 0 D, 0 value for the D input. So when Qn and Qn plus 1 is 1, 0, so we have 0 in the D. And lastly we have for 1, 1, 1, 1 we have 1 as the D input. So 1, 1 is 1, 1 has the 1 as in the D input. So this completes the excitation table. After that we can draw a state diagram from this excitation table. When initial state is 0, next state is 0. When initial state is 0, the next state is 0. That is the self loop at D is equal to 0 and the input D is equal to 0. Secondly, when the initial state is 0, the next state is 1. When initial state is 0, the next state is 1. So we draw an arrow from 0 to 1. When input D is equal to 1, when D is equal to 1, we write D is equal to 1 above the line. When initial state is 1 and the next state is 0. Initial state is 1, the next state is 0, so we draw an arrow from 1 to 0. When D is equal to 0, we write D is equal to 0. Lastly, when initial state is 1, next state is 1. When initial state is 1, next state is 1, so there is a self loop at 1 itself. At input D is equal to 1, D is equal to 1, we write above the arrow. This completes the state diagram of the D flip-flop. That's all about today's video. I hope it's informative for you. I'd like to thank you for watching, and please do like and subscribe.
Subscribe now and press the bell icon. Never miss an update.